Now that you've had practice making a graph that shows distance and time, now we're going to do it backwards and look at what stories these graphs can tell us. So, first we have Bryn walking to and from school. D0 is at her home. D0 would be distance. So here she's home, which means when she gets here, this would be school. T0, again, right here, 0 in time, means she's starting. As she goes on, it's going to take her more and more time. And when she reaches school, the time, you can trace it down and figure out this is how long it took to get that distance. So you can figure out her time. Now, the question is, if this is her walk, she leaves her home and it takes her this amount of time and finally she gets at school. Has she ever started going faster? Nope. Did she ever slow down? No. So she started from home. She starts at home. She goes a steady pace. She travels a steady or the same speed until she gets to school. Directly to school. Number 2, all right, if this is home and this is when she starts, her when, all right, this is her starting when, but is she at home when she starts here? No. She's going to start at school. Where does she go? Well, she almost goes home. She leaves just a little bit. Maybe she stops in the front yard to talk to her mom. Maybe she stops to get the mail. Maybe she, I don't know, let's not have anything bad happen to her. Maybe her dog comes out to greet her and she stays in the front yard playing with her dog. So she goes almost home. How fast does she travel? She goes again at a steady speed. 1 second, 2 seconds, 3 seconds. So she's gone about the same distance. So she travels a steady speed. What did she do to create a graph that looks like this? Well, she didn't start at home, so she started part ways from home. Did she go anywhere? No. If she went anywhere, the line would have to go either farther from home or closer to home. So she starts away from home and goes nowhere. Maybe she's already at school. She starts away from home and goes nowhere. So maybe her mom drops her off at her friend's house, and this marks the point she's been dropped off, and then she stays at her friend's house. If it's a graph of her walking to and from school, is it possible for this to show she is walking to or from school? Absolutely not. So if this is only showing walking to or from school, this is impossible. What about this one? Well, she starts a little ways away from home. She goes towards school, and then she comes back home. In fact, she goes pretty quickly towards school, and then she goes slowly back toward home. She starts away from home, goes quicker toward school, and then she turns and goes home slower. See how it takes more time to go this distance than it took to go this distance. That's why I said she was going quicker this way. If it takes you less time to do that traveling, you must be traveling at a quicker speed. Having that set and thought through, you now need to look at this one. And this is where there's some matching involved. It's a good idea to look at what the X and Y axis tell you first. So as the line travels here, it's going to go the distance from the start, and it's measured in blocks. Going this way, you get more and more and more time measured in minutes. Letter B is measuring distance from the start, but this is in miles. So the higher you get, the more miles you've gone. Over here, this is how much more time. So look at, when you get to this point, there's more time, but you're not going anywhere. So at some point, this graph has stopped. And then it goes back to where it started from. Here, the higher you go in this direction, the farther you are from the starting point. So it starts in one place, goes away, and then comes back. The time, you'll notice there are two lines. One of these lines takes less time to get back than the other. So this line got back to the starting point faster than this line. If it's a race, this is the line that won. They are racing, or they are measuring miles here. This measurement, if you have just an M, that measurement is in meters. So then we look at these stories, and you have to match up which one of these, and I want the letter right next to the point in the story, which one of these matches up with the story that is told in A, in B, in C, and in D. So first of all, this one we have Kelly and Cindy. So we need two lines. Well, immediately you're going to see which one fits this better, C or D. We have two lines. Kelly and Cindy are sprinting from one end of the gym to the other. Well, is your gym miles or meters long? So they start at one end, they go to the other end, then they jog back to where they started. Sprinting is very fast. Jogging is slower. So the sprinting should go up pretty fast. The jogging should be more spread out. Takes more time to go the same distance if you're jogging. Takes less time to go that distance if you are sprinting. It also tells you Cindy was faster than Kelly. So one of them is going to cover that distance quicker than the other, and it's because of the sprint. So the one that gets ahead in the sprint is going to be Cindy. It doesn't matter that you would know which of the lines that is, but it is important that you're able to tell which of these graphs, C or D, matches all the parts of the story. If you're not sure, what I would do is I would find the other story that has two lines that are needed and see if this story matches up better with one of the graphs. There is a right answer. So C or D will go in these two blanks, which means A and B need to match up with these two blanks. It would be a good idea if you sort of wrote part of the story onto the graphs, make some notes about what is going on to help you come up with your answers. Because quite honestly, if all you do is write a letter in these blanks and you don't show me up here how you got it, It's very easy to get a poor score on this assignment. This is the part that you need to think through, photograph, get your notes written on, and send to me. Thank you.